This is the Synthetic Signal Report for Thursday, June 4th, 2026, in the morning. Today, we analyze the introduction of the Gemma 4 12 billion parameter model by Google, the transition of Elixir to a gradually typed language, the emerging threat of AI-developed bioweapons, and the growing bottleneck of semiconductor energy efficiency. We also cover the rise of privacy-native tokens on Ethereum and the urgent security risks affecting the Keystone and Technopass systems. Google has introduced Gemma 4 12b. This is a unified, encoder-free multimodal model designed to bridge the gap between text-only reasoning and visual understanding. Unlike its predecessors, Gemma 4 is optimized for local deployment, targeting a balance between high parameter density and on-device performance. The engineering community has responded with intense scrutiny, particularly regarding the model's weight distribution. Developers are currently testing how this multimodal architecture integrates with existing local-first workflows. The model's release signals Google's commitment to capturing the high-performance local inference market, ensuring that advanced reasoning remains viable for edge devices without requiring constant cloud connectivity. Elixir has reached a major milestone with the release of version 1.20. The language is now officially a gradually typed ecosystem. This is a profound shift for the functional programming community. By introducing static analysis that can catch type errors before runtime, Elixir aims to provide the safety of strictly typed languages like Rust while maintaining its characteristic developer velocity. This update is designed to make large-scale, complex distributed systems more resilient to the vibe coding risks identified in previous reporting, where rapid iteration often outpaces defensive programming. A coalition of AI leaders, including representatives from Anthropic and OpenAI, has issued an open letter to the United States Congress. They are calling for aggressive regulatory protections to close an alarming biosecurity gap. The concern is that sophisticated AI agents could be leveraged to design or synthesize biological weapons. The letter argues that as LLMs gain better access to chemical and biological research databases, the barrier to creating harmful pathogens is dropping. This is an urgent pivot in AI safety, shifting from abstract ethics to the concrete physical danger of synthetic biology in the wrong hands. Two significant research threads are emerging from the Ethereum ecosystem. First, the PERC-20 standard is being drafted to support privacy-native fungible tokens directly on the virtual machine. This standard focuses on enabling confidential balances and transfers, a critical requirement for institutional adoption. Second, the community is exploring a post-quantum public key registry for Ethereum validators. By allowing operators to register quantum-safe keys within current trusted workflows, the network is preparing for a future where quantum computing could threaten existing cryptographic standards. This proactive registry strategy allows for a seamless transition when consensus algorithms are eventually updated. An under-the-radar development in the frontier sector is the release of Recover-LoRA. This framework addresses the accuracy degradation caused by aggressive 2-bit weight quantization in language models. By using low-rank adaptation combined with knowledge distillation on synthetic data, researchers have found a way to reclaim lost precision. This is vital for edge deployment, where memory capacity is the primary constraint. It suggests a future where high-performance intelligence can exist within extremely limited memory footprints, bypassing the need for massive data center-scale inference for specialized tasks. Community sentiment is currently dictated by three primary concerns. First, there is significant pushback against the energy demands of the AI sector. The community is noting that AI is thirsty, with massive water and energy consumption becoming a rallying point for environmental and fiscal scrutiny. Analysts point out that for many corporations, the cost of AI tokens is becoming a huge issue that threatens the profitability of entire product lines. Second, the hardware sector is grappling with persistent bottlenecks. Semiconductor engineering reports that AI-defined vehicles are placing unprecedented pressure on automotive Ethernet reliability, with time-sensitive networking and advanced security protocols now mandatory for safety. Third, the security community is active in addressing a high-severity vulnerability in Keystone, as well as a critical SQL injection flaw in Technopass. These disclosures highlight the ongoing fragility of specialized business software in an era of automated agent-based discovery. Finally, healthcare developers are watching the shift in ambient clinical documentation. While hospitals were the first to adopt AI scribes, the focus is now moving to patient-facing applications. The consensus is that moving AI into the doctor's office as a patient-side note-taker could drastically improve medical records, provided that the data remains locally controlled and secure from exploitation.